So an important thing to remember that when we're looking at linear correlation is that correlation does not imply causation. So let's look at a couple of examples to kind of show that point. So we have, according to the data obtained from the Statistical Abstract of the United States, the correlation between the percentage of the female population with a bachelor's degree and the percentage of births to unmarried mothers since 1990 is 0.940. So in general, that's a pretty strong linear correlation. So does this mean that a higher percentage of females with bachelor's degree causes a higher percentage of births to unmarried mothers? So we would think in general that doesn't make sense. So, kind of looking at this, so certainly not. So this correlation only exists because both percentages have been increasing since 1990, and that's what causes the high correlation. So each variable is moving in a specific direction over time. So in this case, they're both going up in time. So when the data are observational, we can not claim a relation exists between the two variables. We can only claim causality when the data are collected through a design experiment. So let's look at another kind of thing there. So we have something called a lurking variable. So another way that they're related is sometimes through what we call a lurking variable, and the prime example here we have that shows that is ice cream sales and crime rates, and there's a very high correlation between this. So the reason we have a high correlation between ice cream sales and crime rates is, if we think about it, both ice cream sales and crime rates are going up as temperatures rise. So here that lurking variable is temperature, and that doesn't mean that local governments should shut down ice cream shops because crime rates are increasing because ice cream sales are increasing. So it's really important that you remember that just because there's correlation doesn't simply imply there's causation. So you want to really think about that before you're going into that. So that's the key thing you want to remember here when you're doing these, that correlation doesn't imply causation.